Hi, I'm Lauren White. In this lesson, we'll talk together about how to draw an SN2 reaction mechanism. Let's dive right in. SN2 reactions occur in one step. Every time, every reactant, it doesn't matter. It's always one single, we call it concerted, step. Let's look at a reaction together and walk through what actually happens in the mechanism. You can think about SN2 reactions as a love triangle. Say you've got a friend and she has a boyfriend, but they have a very weak bond. The spark is just kind of gone. They're not really that attracted to each other anymore. It's maybe just not really working out very well. So your friend here is our electrophilic carbon. Remember, the electrophilic carbon will either have a positive charge or be bound to an electronegative atom. And she's in a relationship with the leaving group, bromine in this case. But then she's at this party, our reaction, and a new guy comes along. And he's attractive. There's just this instant electrostatic spark. He seems amazing. That's our nucleophile. So our new guy, fluorine, he comes in and he starts pulling our friend, our electrophile's attention away from her boyfriend. Now, there's going to be some period of time where your friend is kind of torn, right? Like, hey, this new guy is great, but I mean, like, old guy used to be okay, and I've been with him for a long time, but new guy, right? So our electrophile is going to have this same sort of period of not being sure where it wants to go. And so what we end up with is called a transition state. And you can see in our transition state, we have kind of hanging on to that leaving group, and we're kind of hanging on to our nucleophile. As it turns out, this is a really high energy state, and it's unstable. And so that's why this transition state only hangs around for a little while. It wants to get to a more stable position, so it's going to finish the reaction. So back to our love triangle. Eventually, the new guy, our nucleophile, he's going to spin some of those electrons, buy her a really nice bag to hold all those protons. The woo game is strong here. Your friend is totally in love with the new guy, ditches her old boyfriend, and has this great new relationship. And then we have our products. We have our electrophile bound to the new nucleophile, and our leaving group is gone. This is the mechanism for every SN2 reaction. So let's review. Single step mechanism. The nucleophile attacks the electrophilic carbon. The nucleophile is going to be bound to our electrophile and force our leaving group off. The intermediate, where it's temporarily bound to both the leaving group and the nucleophile, is called a transition state. Now, the result of this reaction is a net substitution. We substitute the nucleophile for that leaving group. We call these mechanisms a backside attack because it kind of snuck up. It snuck up from behind and stole the electrophile away from that leaving group because it's a little stronger, a little better nucleophile, and the electrophile would rather be with it. This is what you need to know about SN2 mechanisms. And now you should feel more comfortable drawing an SN2 reaction mechanism.